Assalamualaikum dear students. For today's topic, this is also very important topic is called this is topic, the name of the topic is orbital velocity. In previous lecture we have discussed the escape velocity. First of all, before discussing the orbital velocity, I can give you simple concept of a satellite. You know that satellite is an object which is moving around any heavenly bodies or any planet. Suppose we know that moon, suppose this is an earth, moon is moving around the earth in a circular path. This is called satellite of the earth. Just like other heavenly bodies which are moving other planets, they are called satellites of these planets. That means when any satellite is moving around any planet or any heavenly body is moving, it is moving in a path which is mostly called circular path. But we know that when any object moving in a circular path, the natural tendency of any object, if you remember, is every object tries to move in a linear path. That means if it is a path through which a moon is traveling around the earth, the tendency of the moon is to move in a linear path, in a straight line. But there is a force of attraction between the earth which pulls the moon towards itself. This force of attraction, this is called force of gravity, this pulls it towards itself. But the force required to move in a circular path of any object, that force, if you remember the previous slide, that's called centripetal force. That means we know that force is equal to F is equal to mv square divided by r. We have made this expression. This is the, that means any object which tries to move in a circular path requires a force. That force is called centripetal force. This force is mv square divided by r. This centripetal force is here provided by the force of attraction. In equilibrium, the greater this in equilibrium, the gravitational pull provides the required centripetal force of the satellite. This gravitational pulls of any here, the gravitational pull of Earth provides the necessary centripetal force which requires the moon to move in a circular path. But if you remember here, that means this is the velocity through which any satellite is moving through a circular path around any other planet. This velocity is called here orbital velocity. If this, please remember, if this velocity, if this force of attraction, the gravitational pull of Earth and this Earth and the Moon, this gravitational pull of Earth and the Moon, that means it becomes balanced with the centripetal force. If the velocity of this suppose if the velocity becomes greater than this gravitational pull, this force, this planet moves away from this orbital. If this becomes more, gravitational pull becomes more, it becomes closer and closer and will strike this. But here it remains balanced. This centripetal force remains balanced with the gravitational pull. We know that gravitational pull is equal to this force is equal to G, capital M is the mass of Earth, and small m mass of the satellite, divided by r square. यहाँ r क्या है, r square क्या, r is the distance between these two bodies here. That means this force must be balanced with this force. What is then orbital velocity? That means this velocity, orbital velocity of a satellite, is the minimum velocity required to put a satellite in a given orbit around the Earth. That means it is the minimum velocity through which a body or the satellite which is moving around the Earth in a circular path, that velocity is called orbital velocity. That means orbital velocity is the orbital velocity of a satellite is the minimum velocity required to put the satellite into a given orbit around Earth. That means here, if you take, this is the Earth here this is the Earth, it is center, this is Earth. Suppose this is the orbit through which the satellite is moving around the Earth. The height of satellite, suppose above the Earth, is h. Okay, the distance between from the center, this distance between from this satellite is r, where we know that the radius of earth is r, capital R. This is the small r. Okay, I already, m is the mass and r is the radius of earth. M is the mass, r is the radius of earth. We know m is the small m is the mass of the satellite. Capital M is mass of earth. Small m is mass of satellite. Okay, r is the r is equal to r plus h, where r is the radius of earth, h is the height of satellite above the surface of the earth. Okay, I hope you have got this. That means, but the satellite has to move around a circular path. That means it requires a, I already told you, everybody has a tendency to move in a lead. When a satellite moves in a circular path, it requires a force. One force we have already derived, that's called centripetal force. That means the centripetal force required to move a body in a circular path around the planet, around the earth. That means the centripetal force is equal to F is equal to, that means mv square divided by r. Here this v is equal to orbital velocity. That means this is the force required a satellite through which it moves in a circular path around the earth. But according to Newton's law of gravitation, if a satellite is here, this force must be equal, to g, we are already in universal law of gravity, g capital and small m divided by r square. These two forces must be balanced, because if they will not be balanced, मैंने already आपको बताया, if the velocity is more, the satellite moves away from the earth here. If the gravitation pull is more than this, it will becomes closer and will strike through the earth. That means these two must be balanced. When they will become balanced, that means this centripetal force must be balanced with the equal, that they should be in the equilibrium. That means in equilibrium the gravitation pull provides the required centripetal force. That means this must be equal to this. That means in equilibrium we can say m v square divided by r is equal to g capital M small m divided by r square. Small mass and mass, r and r will cancel out. This is, we know this is the orbital velocity. That means v square is equal to gm divided by r, or v is equal to under root of gm divided by r. This is the orbital velocity. Name this first, gm divided by r. But if g is the acceleration due to gravity on the surface of the earth, g is the acceleration, we know that value of acceleration due to gravity goes on changing when we move above the surface of earth or we move towards the center of the earth. We know that at the g is the acceleration due to at the surface of earth. We know that this g is equal to, if you remember, is equal to gm divided by r square, or gm is equal to gr square, where this gr is the radius of the earth. When we substitute in the above equation, we can get v is equal to, instead of gm we can write gr square divided by r. This r is the radius of the earth. This r is the distance between the center of the earth and the satellite. This, if you remember, okay. gm is equal to gr square. I substitute in this value. That means ultimately we can get, I got v is equal to under root of gr square divided by r. Okay. Or we can say here v is equal to, एक में यहाँ निकालूंगा r g, this small r, we know that this small r, if you remember, this small r is equal to r plus h, where r is the radius of earth, h is the height of satellite above the surface of the earth. This small r is equal to capital R plus h. I hope you have got it. Okay. If satellite is orbiting very close to the earth, that means suppose this is the earth, we know that radius of earth is 6,400 kilometer. If satellite is orbiting very close means suppose it may be up to 100 kilometer. Up to 100 kilometer, 100 kilometer or 200 kilometer, up this 200 kilometer is negligible as compared to 6,400 kilometer. I hope if it is at the above the height of 5 kilometer or 10 kilometer, 10 kilometer is negligible as compared to 6,400. That means it is very it we can say if stellite is orbiting very close to the surface of Earth, that means h is very small less than r, because this r, we know that radius of Earth is 6,400 kilometers. That in that case we take this r plus h is equal almost equal. That means we can say that r is equal to r plus h is almost equal to r, because that can be negligible. This 5 kilometers, 10 kilometers, 50 kilometers is negligible as compared to 6,004. In that case, this r plus h will become r. Or we can say, we can substitute in the above equation, we can say is equal to v is equal to r under root of g divided by r. G divided by r. When we this becomes under root r divided by under root r multiplied by under root r. This under root r and under root r will cancel out. Yeah, we can say is equal to v is equal to under root of gr, under root of gr, because r is equal to r can be written as under root r multiplied by under root r. One under root and under root cancel, and d is equal v is equal, that means this orbital is equal to g acceleration due to into radius of Earth. if I multiply, suppose ऊपर से भी मैं सपोज v इज इक्वल टू, अगर मैं अंडर रूट टू से ऊपर मल्टीप्लाई करूँ, टू डी है, नीचे भी अंडर रूट टू से मल्टीप्लाई करूँगा अंडर टू, बट वी नो दैट इन प्रीवियस लेक्चर अंडर रूट टू जी आर इज इक्वल टू escape velocity. It is the escape velocity. That means orbital velocity is equal to escape velocity divided by under root 2. That means escape velocity divided by under root 2. This is also the another form of an orbital velocity. I hope you have got it. Inshallah, in next lecture we will discuss another topic. Thank you very much.